Go and set ourselves in a position where we can see the fan and the switch. What we can do now is increase the dial, and you can see as we increase the dial, the fan is indeed speeding up, and as I bring it back down again, the fan will stop. Let's now add a few finishing touches. So this is already working, but you can see one of the problems we're having here is that basically I'm having to use the mouse far too far to get the dial to work. So let's try and reduce this a bit. So there's a little bit less mouse movement needed to get our dial to turn up and down. So if we go here, really what we want to be doing is dealing with our expression value here. Now something else I haven't talked about yet is basically the importance of getting your project to work the same on different computers. Now this is one problem because the program loop is happening according to your computer speed. So a faster computer will be running far many more program cycles per second than a slower computer. And so if we're doing something which counts, a piece of logic that, for instance, every frame it counts and adds one number in addition to what it had on the previous frame, you'll start having the problem that the speed at which these calculations occur are totally dependent upon the speed of the computer. And a way to get around this is to multiply by the tick count. And the tick count is basically the time it took for your computer to calculate the last frame. So by multiplying by the tick count, you'll basically make something that's frame rate independent. So it'll run the same no matter how fast or slow your computer is. So there's quite a few bits and pieces we've done here that we should multiply by the tick count. Now one of these is looping this relative value here. We've got a relative value here which is being looped. The input we should multiply by the tick count. So what I'm going to do here is A multiplied by TC, and I'm going to put that in brackets, and then divide that by 100. So our fan speed may well have changed now. So let's check it out and see. Okay, I'm having to move this a lot more now to get this. So dividing by 100 is too much in this situation. So let's try dividing by 10 and seeing how that works. So I'm just going to move a little bit closer to our switch so that we can see what's going on. So whilst we're now happy with the way in which the dial's working, one thing I've just noticed is that in actual fact it's working the wrong way. Really I want the mouse up to be making the dial rotate clockwise and down to make it rotate anti-clockwise. So what I'm going to do is double click the expression here and put a negative before all of this. So let's see how that works now. So you can see now it's working much better. So I move the mouse up and the dial is turning up. I move the mouse down and the dial's turning down. So there's a couple more things we have to do before we're finished. The first of which is to make the rotation of our fan frame rate independent. At the moment the rotation for our fan is not being multiplied by the tick count, and we do need to do this, otherwise the fan will rotate slower or faster depending on how quick the computer is which is running the project. So I've just added an expression value above our envelope here which is going into our loop relative value, and all we're going to put here is A times TC. So we're taking the output from our envelope, multiplying that by the tick count, and then that's going to be the value used in our loop relative value channel here. So let's go and check this out and see if the fan rotation is still going at approximately the right speed. So you can see I've turned the fan up a fair way there and it's okay. Now on full speed, that's the kind of fan speed, so that looks alright. And then if we bring it right down to something very low, yeah, that looks perfect. So the only other thing I think we need is some kind of damping, because we want the fan to gradually speed up and slow down. So all we need to do then is go to our channel section, get an inertia channel from the channel list, and we're going to put this above our expression value here, and this is going to go into our loop relative value. So we've got that in there. We want a lot of damping on this, so let's put something like 0.05. And now let's go back to the animation section and see how that's working. So you can see I've now turned it down to 0, and you see our fan is gradually stopping. Very gradually. For the final stage in this tutorial, we'll be looking at how you can use a movie as a texture. So you can see I've just imported a television object here and connected it to the renderer. So it's now visible in our room in the corner here. What we now want to do is display a movie on its screen and have a switch so that we can turn it on and off. So first of all, let's try and get a movie texture applied to it. So if we go to the channel switch and then channel list and then go to M and find media texture, what we can do is replace its current black texture with our media texture here. Now if we double click the media texture and hit load, we can then go and browse, find a movie, load it in, and you see there's a few settings here. I've set it to play, and it should play after it's loaded, and basically it's playing about at a rate at 1 and it's looping. Everything like that's fine. So we're going to close the dialog now and have a look at it in the animation section. So you can see now our movie is playing on the TV fine. But what we might want to do is add a reflection over the top of this. So TVs mostly have a fairly reflective surface, so let's create some reflection on top of that. So let's go to our templates and get our cube map again. So if we go into scene and simple scene with cube map, what I'm going to do is just delete all of the channels except for our cube map texture. And I'm going to apply that as our second texture stage. So let's now go to the object section and find our TV object, which we have here. And then the next phase is to find our second texture stage. Let's set it to cube map reflection on that stage, which it already is. And now we've got to change its color blending. So it's on blend factor alpha, which is correct. So we can now use our texture factor slider to determine how much of this reflection we see. So at the moment you can see in the object section we're getting full reflection. As we turn it down we get more and more of the movie texture. So if I put it at something like this and now go back to the animation section and move around, you can see we are getting a reflection on top of our TV screen. So let's now just quickly create some logic so that we can turn our television on and off by clicking on it. So it's going to be the same process as we've done just with the fan there. So we want a shortcut from our object. We then want to, in our channel list, get a detect mouse collision. We then want a value operator, and we're going to set the value operator to a triggered toggle value, so that's now working. We need an expression value, and we want a user input to make sure we are clicking with the left mouse button. So I'm just going to put our mouse collision and our our mouse click and our detect mouse collision both up to our expression value and have an A and B expression inside. We can then connect the expression value up to our trigger, and what I want to do then is use that for a channel switch to switch our media texture between the black, which is our TV off, and the media texture, which is obviously the TV being on. So let's get a channel switch. We've got to set that to type texture, and that is now a texture. We can link the channel switch up, and our switching logic is then going to be linked up as the switching value for our channel switch. So let's see if this now works. When we put our mouse over and click, it should turn on. It does. We put our mouse over again and click, it turns off. So we started off this tutorial by positioning and parenting the fan and its switch. We then created some logic to make the fan rotate. We then started working on the interface, first detecting mouse collision, then disabling the camera rotation, and then finally created some logic to make our dial rotate. We then worked on linking the interface and the fan. So we started this by using the dial to speed up and slow down the fan. We then used envelopes and then added a few finishing touches. Finally, we looked at using a movie as a texture for our television. In the next tutorial, we're going to create a sound for our fan, which has its pitch altered depending on the speed of the fan, and has its volume altered depending on the camera's distance from the fan. We're then going to create an outside ambient sound, which turns on when we're outside of the house, and off again when we're back inside.